Hi, it's time for another math easy solution here to discuss further into limit laws and basically go over some examples. I showed in my earlier video brief overview of limit laws, and now let's recap what this is. Just these first 5 laws here, and then I'll go over a useful example here. Basically, the limit law states, let's just suppose that c is a constant and limits below exist. This one here, limit fx as x approaches a, and also a limit as x approaches a of g of x. Then law 1 is the sum law. If you just do a limit of two sums like this, then it equals the limit of these two. It's just the sum of these two limits. And also this one, subtraction. This is going to be the difference one. As you can see, you could just break apart this difference and then just put it together like this with limits. And also with a constant, you could take it out with law 3 and law 4 states. If a multiplication like this, it just equals to the limit of these both separately, and also same for law 5, but with division here. So all you do is take the limit. If it's something like this, you just take the limit of each one separately if the limit at the bottom is not 0 here. So you kind of get it divided by 0. So now let's go over an example here. Let's go this example right here. Let's say if you're given these two functions, they look something like this. Here, as you can see, there's this is continuous, but as you can see at this point, it doesn't actually equal one here for f of x. Yeah, this one here, the limits here is approaching 1, but here the value is actually 2. So then if you look at g of x, it's a discontinuity at this point here, just straight lines across. So you got two functions here, and now basically the example, I just want to go over these 3 brief examples. Basically solve the limit as for these 3 ones here. We'll look at number 1 first, or part A first. It's a limit, find the limit as x approaches -2, so it's approaching this right here, of f of x plus 5 times g of x here. So g of x is the blue, just keep that in mind. So as you can see from this one here, this one's approaching, well, for the f of x, this is approaching, well, 1, the value of 1. So as x approaching -2, we're going to get, well, actually, before we get to that, I just want to, use our limit laws here. So now we have this function here, and this one here, we could use the sum law, so this equals to the limit of these separately, because we can find out what they are separately. Because this one here, the limit of f of x as x approaches -2 is just going to be this value right here, which is 1. And for g of x here, as you can see, this point it's reaching 1. It's approximately 1. I think it is a -1 here. So when it approaches to this point right here, it's -1 for g of x. So we could do this separately. So what we could do, you could just break this apart. This, if we want to use the limit laws exactly, or you could just plug these in, knowing if you know all the rules already. But basically, let's assume we don't. So we break this up. So limit x approaches -2. So yeah, if you break it apart using the sum law, you get this limit x approaches -2 of 5g of x. Then using the constant multiple law, or this one right here, this constant one, you just take the constant out, and we're gonna just get now. Yeah, we're gonna just get now this little function right here with the 5 out of the limit of the g of x, and like I stated before, the limit for this f of x as x approaches -2 is gonna be 1, and then but for the g of x is approaching -1 right here. So we just plug those values in and we'll get our answer. So this one's gonna be 1 plus 5 times limit of g of x. This one is just -1. So add these up, 1 plus -5 is equal to -4 is our answer. Okay, so now if we look at part B, which basically stated limit as x approaches 1 of f of x times g of x. Well, before we even look at the graph, we just apply our limit laws. This is just equals to the product law. So you can just do this separately for each one here. So limit as of the f of x times by the limit as x approaches 1 for g of x here. Now we just solve these separately from the graph here. So when we look at this one, as it approaches the value 1 here, so for f of x here, as it approaches this value right here, yeah, as it approaches this one, it's approaching right here at this point here. Let's call this 2. So we could write down this value right here. This is the limit of the f of x. This is equals to 2 times of it. Now we have to find the limit of this one here. Yeah, so when we look at the graph for the g of x, now as it approaches here, now you're going to have this discontinuity here. So if you approach from the left side, you're going to get a value of -2. And if you approach from the right side, we're going to get a value of -1. Yeah, and I'll just write that down here. So -2 or -1, you don't know which one it is, or you could write this in the other notation, limit as x approaches 1 from, let's say, the negative side, which is, or the left side is a negative, g of x is going to equal to -2, and limit, yeah, as x approaches 1 from the right side, or the positive, g of x equals to -1. Thus, these are just one-side limits that are not equal. Thus, the limit does not exist. And thus, the limit does not exist for this. And also, since you're multiplying a limit here by something that doesn't exist, part B, the answer is basically limit does not exist. So now if we look at part C, basically limit as x approaches 2 of fx divided by g of x here. Once again, before we look at the graph, let's just use our limit laws here. The last one, the quotient one, we're just going to be fx divided by, now you just do it separately here. So the limits are going to be division of limits now. Of g of x, now we can look at the graph. And when we look at the graph right here, so this is as x approaches 2. So as you can see, for g of x here, it's approaching at 0. And for this one here, I'm not sure what this value is. Let's just call this, I don't know, 1.5, I guess. Let's just call this value 1.5 roughly. So roughly 1.5. So we got 1.5 here for f of x. This is approaching here. There's no discontinuity, so we do have a limit. And this one's approaching 0. There's no, we have a limit right now. Yeah, so the top one's gonna be, this one is just gonna be, let's say around 1.5. Then divided by now 0. So you can't divide it by 0 right here. So this is not defined. Because if you recall, you can't divide anything by 0. You're just gonna have, it's not defined. You're gonna have infinity or whatnot. So basically, limit does not exist. Yeah, so that's the answer for this part C, and that's hopefully learn from this one. That's all for today, actually. So you can see part B and C, both limits do not exist here. Just wanted to go over how you could use limit laws, but once you get a hang of it, you could just basically plug in directly here. If you know this value here is, let's say, if you knew that it was 1, this was negative 1, you can just plug it in and solve it directly. But this is good to know. This will show the proofs for these are more. The proofs are pretty complex. Show them in a later video. So hopefully you learned, and yeah, stay tuned for another math easy solution.